Okay, so this is naming ionic compounds, and you're going to need to have your gold sheet, as you can see over on the right. That is my gold sheet. And I'm going to do a few examples for you. So, and this is the naming side, not the writing the formula side. So let's look at number 1. And what I want you to recall is that there's always a cation and an anion. Okay, you can divide these all in the middle, and one side's the positive, one side's the negative. Okay, like this. Now, if you recall in a different video, I said that if you have more than one, or excuse me, pardon me, more than 2 capital letters, like you can see right here, there are 3, and here there's only 2, and here there's 2. If you have more than 2, that means you probably have a polyatomic ion. And polyatomic ions require you to look at the gold sheet, unless you have memorized them, which a lot of people do pretty quickly. So what you're going to do is, if you remember for ionic compounds, the cation always just is the name of the element. So this is potassium. And if we look over here on the gold sheet, the OH is hydroxide. So that ionic compound is potassium hydroxide. Let's do another one. Let's do aluminum fluoride, which, oops, I just kind of gave that away. But okay, so aluminum is the cation, aluminum. And then F is fluorine. So, and you can actually see it over here, fluoride. And remember, you're going to have this exact thing on every single assessment, every single test. You're always going to be able to use that. So as long as you know how to use it, then you should be okay. So that is aluminum fluoride. Let's do number 4 right here, okay? This takes a little bit more thought, and the reason why is because iron is a transition metal. And if you look again over here, this is the little section on your gold sheet about transition metals. And I want to point out to you that you have iron right here, okay? And if you look at this, there's 1 iron and 2 chlorine, okay? Now, chlorine, if you look on the gold sheet, has a charge of 1 minus. You also could have remembered that on the periodic table, you have your transition metals, 3, 4, 5, 6, 7, 8, okay? And family 7 is where chlorine is, and it has 7 valence electrons, and therefore it gains 1 so that it has 8, and then it ends up with an ion of a charge of -1. So chlorine is -1, and there are 2 of them. And remember, the charges are equal but opposite. There's 1 iron, okay? So on the anion side, we have a charge of -2. And so on the cation side, which is the iron side, we're going to have a charge of +2 in order to multiply that out. 1 times 2 is 2. So remember that ionic compounds are always neutral, and that's how you can use that method to determine which of the different charges is present. So since it's 2 plus, 2 plus is right here, and you would put iron, Roman numeral 2 if you're using the stock method, and then chloride. If you want to use the us-ic method, it would be ferrous chloride. Now, I prefer you use the stock, which is the Roman numerals. Let's do one more. Let's do, I guess let's do this one right here. I don't remember what number it is. I cut it off. But if you look at this, you have 2 sodium, and then you have 1 carbon, and then you have 3 oxygens. But I want you to notice that there's 1, 2, 3 capital letters, which means there must be a polyatomic ion. And that polyatomic ion, which I'm going to abbreviate PI, is CO3. Okay, so then a clue that the polyatomic ion is the right-hand side is because you have this 2 here for the sodium, and that kind of breaks it apart. So this side is the positive, and this is the negative side. And so CO3. If you look over on the gold sheet, CO3 is right here. It's carbonate. And as we already knew, this sodium, Na is sodium, so the name of it is sodium carbonate. So the hardest thing for people is being able to recognize when there's a polyatomic ion. So uppercase letters is a clue. And what you're going to, and I'm just going to remind you of this again, and we'll just keep harping on it, is that ionic bonds are metal to nonmetal, metal to polyatomic ion, okay? Or in some cases, it's polyatomic ion to polyatomic ion. Okay, let's do one more. And I'm going to do this one here with copper. And you just have to get used to the fact that you're going to have to kind of recognize when you have a transition metal, and copper is a transition metal. Okay, and you can see it right in here. And then since there's 1, 2, 3 capitals, that's kind of a clue for you that there's going to be a polyatomic ion in there. And the polyatomic ion is this NO3. It's all bunched together in the parentheses because this whole thing always will travel as a unit. And NO3, if you look over here, is nitrate. Okay? Now, nitrate has a charge of 1 minus. And there are 2 of them, as you can see right here. And the charge on the other side, the positive side, needs to be equal but opposite. So if this is 2 minus, then this has to be 2 plus. And there's only 1 of them, so that must mean that the charge on the copper is 2 plus. So it's copper to nitrate. Sorry, I wrote messy. Okay, you can keep doing that on your own on the remaining questions. I did an example of each of the different types, and don't worry about the back just yet. That's for a different video.